Okay, so we're going to start talking about how to graph linear functions. And in the last couple days, I talked a little bit about independent and dependent variables. Remember, the independent variable is your x value or your x values if you have multiple of them, or they are also considered the inputs. So usually when we talk about independent variable, we talk about things like time, because time is something that we end up choosing. We decide how much time we're going to work or how much time it takes to cut the grass or something like that. The dependent variable is the y value or the y values. Those are the outputs. So typically you will see something like, if we're talking about how much time I want to work, the dependent variable would be the amount of money that I make. So I'm deciding how much I'm going to work, and the value or the money that I earn is dependent on how much time I'm working. So what we're going to do is we're going to graph using the graphing calculator today. We are not going to be graphing the way that you did in middle school. Rather than read through all the steps on how to use the graphing calculator to graph, I'm just going to go right to the graph and show you, as I graph, I'm going to show you how to use the graphing calculator. But keep in mind, the set of all solutions of an equation forms the equation's graph. A graph may include solutions that don't appear in the table. This is kind of a big one because a lot of times I'll get tables from people and then they'll only graph what they see in the actual table instead of graphing the entire function. You have to remember that that table can go on indefinitely in both directions. Also, a real-world graph should only show points that make sense. So for example, if I'm talking about the number of hours that I work and the amount of money that I make, then I'm talking about positive numbers all the time. Okay, so if we go down to problem 1 where we're graphing a function rule, it says, what is the graph of the function rule y equals negative 2x plus 1? Now when you were in middle school, you made an xy table. You would put the function in the middle and the y value off to the side. And then you would pick, you probably picked from negative 3 to 3 or negative 2 to 2 to graph. I'm going to try to get you out of that habit. You don't always have to graph negative 2 to 2 or negative 3 to 3. We can graph any values we want. So for example, if I wanted to, I can graph negative 1, 0, 1, 2, 3, and 4. Now in middle school, what you would have done is you would have substituted negative 1 in for x, and you would have calculated what the y value would be. So negative 2 times negative 1 is positive 2, plus 1 is 3. And then you would have substituted in a 0, and then you would have substituted in a 1, and then you would have substituted in a 2, and then substitute the 3, and then substitute the 4. And then you would go ahead and plot those points. So I'm graphing the way that you would have done it in middle school. Remember that you must label your axes. If your axes are not labeled, I take points off. X is negative 1 when y is 3, so I'm going to plot that point. 0, 1 I'm going to plot. 1, 0. Something's wrong here. Negative 2, this should be... When x is 1, y should be negative 1. So 0, 1, 1, negative 1, 2, negative 3, 3, negative 5, and 4, negative 7. You're then going to take your straight edge. Remember, if you don't create a line with a straight edge, I am not giving you full credit. You must use a ruler when you are graphing lines. Make sure you have an arrow on both ends of your line. Make sure you label your line. Y equals negative 2x plus 1. Now, that should not be new for you. That's the stuff that you saw in middle school. The difference between what you are going to do in high school and what you did in middle school is we no longer use this middle column here. We are just going to use the graphing calculator to get our table of values. So if we go to the next equation, we have y equals 1/4 x. So notice that my xy table, I don't have that middle column anymore because I don't need it anymore. The graphing calculator is going to do the work for me. So what I'm going to do is turn on my graphing calculator, and I'm going to hit the y equals button. The y equals button is right above the second key. And I'm going to type in y equals 1/4 x. And then I'm going to hit the table. So the table is right above the graph button. So if you look at where the arrows are and you go above the arrows, you'll see the graph button, and the table is right in blue above that button. So I'm going to hit second table, and I'm going to get my table of values right from the graphing calculator. Again, it doesn't matter which x values you use. You could use whatever x values you want. So, I mean, you may not want to plot fractional points. You might want to plot nice integer points. So I'm going to pick -4, -1. And I'm going to keep scrolling until I get some nice points, like 0, 0, 4, 1, and 8, 2. So this way I don't have to deal with any of the fractions. Now when I plot my points on the graph, I'm going to plot -4, -1, 0, 0, 4, 1, and 8, 2. Don't forget to label your axes. Again, if you don't have your axes labeled, I am taking points off. We're going to take our straight edge and we're going to connect the points. Make sure you label your line. Make sure you have arrows on both ends. Because remember, this line, this linear function, goes in both directions forever. It is not just what you have on the table or the table that you're looking at inside the graphing calculator. Now, when graphing real-world function rules, make sure you choose appropriate intervals for the units on the axes. So you might not be counting by ones all the time. You might have to count by hundreds or even thousands. Every interval on the axis should represent the same change in value. So each line on the grid is going to count for the same amount. And if all the data are not negative, we're only going to show the first quadrant. So for example, if I was talking about how many hours I worked and how much money I'm making, I'm not going to show all 4 quadrants because I'm only talking about positive numbers. Okay, so let's take a look at a real-world situation. The function rule W equals 146C plus 30,000 represents the total weight W, so W is the weight, in pounds of a concrete mixer truck that carries C cubic feet of concrete. So C is the cubic feet of concrete. The capacity of the truck is about 200 cubic feet, which means that that's all the truck can actually hold. What is a reasonable graph for the function rule? Now, here's the thing. They're giving me the C values. They're saying C can go anywhere from 0 all the way up to 200 because that's the capacity of the truck. But keep in mind, if I were to use my graphing calculator for this one, I'm not going to sit here and scroll up to 200. That's going to take me far too long. So in this particular situation, it would be better to do it the way that you did in middle school and substitute each one of the x values, or C in this case, substitute each one of the C values into the function to get the corresponding weight. So here's the thing. While you can use the graphing calculator to graph, and it's a great thing, you cannot completely rely on it 100%. You have to be able to remember how to do it the middle school way because we're going to have X values or inputs that are in the thousands or tens of thousands. So what we're going to do is we're going to finish substituting and finding the weights. So I'm going to pause the video. I want you to complete the table, and then when you come back, I'll have the table finished and we'll talk about how to graph it. Okay, so I have my table filled in now, so I just want you to double check the values that you got with my values and make sure they're all correct. Again, keep in mind that the reason I did it this way is because I didn't want to scroll up to 200 in my graphing calculator because that would have taken way too much time. All right, so when I graph, first of all, notice that I only have a first quadrant graph, and that's because there's no negatives in this situation. There will never be negatives in this situation. I'm going to label my x-axis as cubic feet of concrete. Oops. And I'm going to label my y-axis as the weight. So this is going to be the weight of the truck carrying a certain amount of concrete. Now, in my C-axis, or in the cubic feet of concrete, I go from 0 to 200. So I'm not going to want to count by ones. I'm going to have to change my scale, definitely. And how you choose to count is completely up to you as long as each line counts for the same amount. So I might want to consider counting by tens. So if I count by tens, each line is going to be 10. So 10, 20, 30, 40, 50, would be the fifth line. 60, 70, 80, 90, 100. So each line, again, is counting for 10. 110, 120, 130, 140, 150, 160, 70, 80, 90. And I'm actually out of space. I probably shouldn't have counted by 10s. I probably should have counted by 20s. Now, on the y-axis, or the w-axis in this case, that's a little bit trickier because we have to go all the way up to 59,200. So I got to get up to 60,000. So I might want to consider counting by 1,000, or I'm sorry, I might want to consider counting by 10,000s. However, these values are pretty close to each other. So rather than squeezing everything all together, I'm actually going to break my axis, and I'm going to start at 30,000. So I'm going to start at 30,000, and I'm going to count each line as 2,000. So 30, 32, 34, 36, 38, 40,000, 42, 44, 46, 48, 50,000, 52, 54, 56, 58. And I'll have another point that's just a little bit off the graph. So now what we're going to do is we're going to plot our points based on the table. So when the cubic feet of concrete was 0, I had 30,000 pounds for the weight of the truck. And then when I had 50 cubic feet of concrete, it was 37,000. So 30, 32, 34, 36, 37 would be in there. Of course, we're estimating because we had to change our scales. For 100, it was 44,600. So I got to go up to 44,000, 32, and a little bit more. Then 150 was 51,900. So I'm going to go up to 51,000. And then at 200, I had 59,200. So just right there. Now, here's the thing with this situation. Because there's a capacity to this truck, I am not going to have arrows on both ends. First of all, I can't have negative weight, and I can't have negative amounts of concrete. But the other thing is, I can't go beyond 200 because the capacity of the truck is at 200. So I have to stop my lines. Instead of graphing an actual line, I'm going to graph a line segment. I'm going to label my line with W equals 146C plus 30,000. I have labels on my axes, I have appropriate scales, and I have my line labeled. Now, to figure out what the independent and dependent variable is, the dependent variable is usually on your y-axis. That's the one that depends on the other. So the weight of the truck depends on how many cubic feet of concrete there are in the truck. That means that the independent variable is the concrete, or the cubic feet of concrete. So concrete in cubic feet is going to be my independent variable because the weight of the truck depends on how much concrete there is. Okay, now let's talk about the difference between continuous and discrete graphs. We've actually already talked about this earlier in the year, and we said that continuous graphs can have parts. So if you think back, we had questions on, I think it was the number of pages of a book you read and the amount of time you spend, or the number of hours you spend reading. That's a continuous graph because you can read for parts of hours. But then there was another problem where it was teams and number of players. Now, you can't have part of a team or you can't have part of a player. So in a discrete graph, you cannot have parts. So you have to recognize the difference between continuous and discrete. So what I want you to do is I want you to try problem 3 on your own. I'm going to have you pause the video. When you come back, I'll have problem 3 completed, and then we can talk about which one is continuous and which one is discrete. Okay, so in our last two graphs here, the question regarding the weight of cheese depending on the number of gallons of milk sold, well, we can have parts of a gallon. So if I made cheese and I was using parts of a gallon, then this is going to be a continuous function because I'm going to use parts of a gallon of milk to weigh my cheese. The weight is the dependent variable because the weight of the cheese depends on how many gallons I used. In the second question, the amount of money made from selling the cheese depends on the number of wheels sold. Now, typically when cheese is sold in wheels, it's sold as entire wheels. They don't cut up the wheel of cheese, so that's why that graph is continuous. What I want you to notice is my scales. Each line counts for the same amount, even though I didn't count each line for one. So I have even intervals on my X and Y axes. I have both my X and Y axes labeled, and I've discussed which one is continuous and which one is discrete. So with any time remaining, you're going to be working on your homework, page 257, 6 through 8, and 9 through 23, the odds.